Welcome to AP Physics video 2 for forces, and we'll do a little bit more complicated examples now. So we have a chair being pulled up an inclined plane now. So let's draw forces on that. So we have a force going upwards. We'll call that the force applied. And we have possible forces going against that motion. Force gravity X and force friction. Let's draw two vectors for that for right now. And again, we describe those in a moment. Okay, so where do we get these two forces from? Well, let's remind ourselves. Straight down, of course, always is force gravity. This will make a triangle that looks like this. So we're splitting gravity into different vectors now. So there's all of our forces right there. So let's label all of those so that we can get a good understanding of what they are. Okay, the one going up is force applied. Straight down, as always, is force gravity. Okay, and we do open up this angle here. We see that there's 15 degrees there, would be this 15 degrees right here. So we call this one force gravity in the y direction because the incline is splitting gravity up. And this will be force gravity in the x direction. And the one going upwards is force normal. So one more time, we have force normal equaling a component of gravity, in this case force gravity y. So force normal is equal to force gravity y. Okay, but let's remember that this side of the triangle, here's our hypotenuse. This side is touching the angle, therefore that's the adjacent side. So force normal is going to equal mg cosine theta. Because remember, force gravity is mg. Force gravity x is then going to equal mg sine of theta. It's the opposite of the triangle there. So let's put force gravity x here. Force gravity x is going to be opposing the motion going upwards because it's pulling down the incline. And then the other force going against that motion would be force of friction. Okay, now remember, force friction is always force normal mu. That never changes. But how we get force normal can definitely change. In this case, force normal is mg cosine theta. So what is our net force equal to? So force net in this case would be force applied minus force gravity x minus force of friction. Because both these forces, okay, do go against our applied force going upwards. Now, friction force is always a mystery. What direction does it point? I just remind you that force friction always points away from the motion that the object wants to go in. So, for instance, let's say we remove the applied force here. Well, then force gravity x is going to be pulling this downwards, and friction force would be opposing that motion. So if we write that equation, okay, I'll write it down here so we don't get too confused. Force net, in that case, would equal force friction minus force gravity x. Okay, because now force friction is going to be pointing in that direction because the object's going to want to go down, which is left according to my xy coordinate system. Remember, moving left is negative, and anything pointing upwards is positive. So if this object was simply sliding down, that would be its force net equation. Because friction always opposes the direction that the motion actually wants to go. Okay, now what about another example? Okay, let's say we have two buckets. Okay, and they are accelerating upwards with this force tension number 1 going up here. And of course, there would be a force tension 2. Okay, that's also being applied here. Okay, so if we want to get the acceleration of this system now, we're going to say we've got force tension 1 upwards, and opposing that is going to be equal to the force of gravity of both of those objects. So we're going to say then force net equals force tension 1 minus the force of gravity, okay, of both objects here. Now we're going to assume In this example, there is no air resistance at all. Okay, so what would that actually look like? And we're going to put some numbers but not actually calculate this, just so that you can see, okay, what it actually looks like. So force net, I'm going to add both of those together. So I'll have 16A is equal to force tension 1, okay, minus, then I'll have 16 times 9.8. And then we can figure out, what tension force we want to have if we're given an acceleration, or if we're given an acceleration, we can figure out, okay, what force tension we have, whatever we want to find out there. But either acceleration or force tension 1 is going to have to be known in order to solve that system. Okay, now what if I wanted to find out what force tension 2 equals? Well, we're going to write another equation for that. So force tension 2, okay, I'm just going to kind of label that there if I want to find force tension 2. Okay, so then I'm going to say force net equals, this will be going upwards, force tension 2 minus force gravity. Okay, then force net, in this case, force tension 2 is only asking for the 9 kilogram accelerator, so I'm going to say 9A equals force tension 2 minus 9 times 9.8. Because remember, force gravity is mass times 9.8. Okay, so there you have it. Force tension 2 is only pulling up 1 mass, so that's why there's only 9 here. But force tension 1 is pulling up 2 masses, so that's why we have both of those things added together. And that's our second video. More to come.